title of my project is Outsole. It is a unique outsole designed for sports footwear to enhance support and performance. This presentation will focus solely on football boots. The inspiration for my project came when I noticed that 5 of the English national football team, including Wayne Rooney, fractured their metatarsals. I researched the causes of this injury and found that it is often due to excess foot flexure. There are 5 metatarsal bones in each foot. They are the largest bones connecting each toe to the ankle. Therefore, I wanted to design a football boot that would achieve a targeted reduction in foot flexure, without compromising on performance, but instead perhaps improve it. My solution is to create a castellated outsole, as in this video. As demonstrated in the image on the left, the castellated outsole will provide normal flexibility during running. However, in the event that the foot is overflexing, the ridges will meet and provide the necessary support. As in the image on the right, a secondary feature is that an elastic material may be installed between the ridges. This material would serve to absorb energy during running and return it rapidly during the toe-off phase of the gait cycle, thus improving a player's acceleration. Initial proof of concept testing was carried out. The test piece in the image here was used to demonstrate the change in stiffness once the ridges met during a 4-point bending test. The results of test pieces of thicknesses ranging from 1 to 5 mm were recorded. As you can see, each test piece demonstrated a sharp rise in stiffness once the ridges began to meet. The following steps were taken to produce a prototype. Several materials were considered. Due to their respective mechanical properties, a combination of polyurethane, elastic adhesive shown in red in the following video, as in the interridge material, carbon fibre and Kevlar were selected as the most suitable materials to build a prototype. Many different techniques were employed to develop a rudimentary prototype. The most successful method was the use of epoxy polyurethane resins of varying shore hardnesses, poured and set in molds formed by a 3D printer. Virtual prototyping was carried out using finite element analysis. A large displacement stress analysis was carried out on the design to mimic the real-world stresses of outsoles and football boots. This analysis was also used to optimize the fatigue life of the outsole. A fatigue testing rig was constructed to demonstrate the fatigue life of the outsole would not be adversely affected. Modern football boots are designed to experience over 1 million bending cycles before material failure will occur. Finally, gait analysis was employed to highlight the benefits to a player's performance when the elastic interridge material is installed. Elastic shims were placed inside the running shoes, as in the photo on the right. Using high-speed cameras and multi-axis accelerometers, the results found indeed demonstrated slight improvement in acceleration. So that's the end of my presentation. Thank you for watching.